Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem solving skill. First, we will analyze the problem on hand to find the related concepts. Then using these, we will develop a method which will produce a solution. This will help the students aspiring to get into IIT to understand the much needed advanced theories and applications in physics. In this video tutorial, we will discuss a problem on the force and torque experienced by an electric dipole in a non-uniform electric field. The question is as follows. In a certain region, the electric field is along the positive direction of z-axis throughout. The magnitude of this field is not constant but increases along the positive z direction at the rate of 10 to the power 6 Newton per Coulomb per meter. A system of charges having net dipole moment 10 to the power minus 8 Coulomb meter in the positive z direction is placed in this field. Find the force and torque acting on the system of charges. Before proceeding to solve the problem, let us recall the related concepts. Dipole moment of an electric dipole consisting of charges minus q and plus q separated by distance 2a is equal to 2aq, which is directed from minus q to plus q. When an electric dipole is placed in a uniform electric field, equal and opposite forces act on the two charges such that the net force on the dipole is 0. When the direction of the dipole moment P makes angle theta with that of the electric field E, the torque acting on the dipole is tau is equal to Pe sin theta. When the dipole moment is parallel to the electric field, torque on the dipole is equal to 0. When the field is non-uniform and the dipole lies parallel to it, then the torque on the dipole is equal to 0 since sin theta is equal to 0. But a non-zero force acts on the dipole. Now we are in a position to solve the problem in the question using these concepts. Given that both the dipole moment and the electric field act in the positive direction of z-axis. Therefore, theta is equal to 0, which implies torque on the dipole is equal to 0. Again, let the field at A is equal to E and that at B is equal to E plus delta E. Therefore, force on minus Q is equal to minus QE and that on plus Q is equal to Q into E plus delta E. Therefore, net force on the dipole is equal to F plus F minus, which is equal to Q into delta E. But change in the electric field delta E is equal to rate of change of field into distance AB. Therefore, F is equal to P into rate of change of field. Now, P is equal to 10 to the power minus 8 Coulomb meter and dou E by dou Z is equal to 10 to the power 6 Newton per Coulomb per meter. Putting these values and simplifying, we get F is equal to 10 to the power minus 2 newtons, which completes the answer to the question.